going to run perfectly. Unless you are sure, you should not start writing the program. So all those things you should do in analysis. See, for movie making, if you start analysis, movie cannot be made. You cannot make a movie, right? Suppose you have to shoot at India Gate. Now, on which date it will be free, whether that minister or that so-and-so person will give permission for shooting. Just analysis you do. You cannot do it practically. And if you say analysis on so-and-so day we have to do, if it cannot be done, then that shot you have to remove from the movie, isn't it? So you cannot do analysis. So that is on trial and run. Let us do it. Let us do it. No, it doesn't look good. Change it. But in programming, in engineering, you cannot do. You are making some car. No, this color is bad. Change the color. The doors are bad. Change the doors. No, you cannot do that. So in programming also you cannot do, because software engineering, we are saying. So when you said engineering, follow the principle of engineering. First do proper designing, perfect design. Then start writing the program. So anyway, I have spoken enough for you to understand the importance of analysis than production, right? So this is designing, that is construction. Design on a paper and start constructing on a land. Suppose you are making a house. Design on paper, then start construction on land. Alright? Now come to it. Now the question is, now I'll come to this one, pre-array analysis and post-array testing. I already wrote the heading. I asked you not to copy it. Now let us come to this. How can we know how much time algorithm takes? Actually, program takes the time. So when you find the time, you get watch time. Then when you analyze an algorithm, can you give watch time? You cannot give watch time. Then the analysis will be more mathematical. Then what we get? We get time function. We get time function. So analysis is more mathematical, right? So we get a function. There, watch time, run the program and see, okay, this much time it has taken, right? Or let the program itself display starting time and ending time and calculate how much time it has taken. Algorithm, there is no program yet. Then we also get space time. And here, sorry. We get a space function, right? And here we get memory in bytes. These many bytes it is consuming. So for everything we get function. So this is more mathematical. Analysis is more mathematical. So pre-array analysis is more mathematical. Post-array testing, we check whether what we thought, are we achieving the same thing or not. It should work. It should work. So then your analysis was perfect. It's not verifying analysis. Analysis we did perfect and said this will work. Then test it. Anything when you manufacture, you have to test it, right? I said this car will start with this speed or this torque. So after manufacturing, it should run like that only. So yes, I said what I said, that's happening. So all was your analysis, right? Sending a rocket or satellite from here to Mars and said that this will reach in 3-4 years and it will land there. It should land. Then your analysis were perfect. We cannot do this, shoot it, oh, did not reach, send another one. We cannot do that. But, right, so we cannot do that. So, but we have to do thorough analysis, then start writing the program. So finally, one point, again I repeated the same thing, right? I have given you different examples. Now 1 point. Analysis is done by using mathematical procedures upon an algorithm to find out how much time and how much space and how much power, whatever it is consuming. We get function, time function, space function. This, we get the actual time, actual bytes program. So that is post-array testing. Then this will be, pre-array analysis will be independent of language, operating system, and hardware. This is dependent on them. All these things, it is dependent, right? So language, OS, and hardware, it is dependent on all these three things. So this is independent. Okay, so pre-array analysis, we don't consider any particular language, we don't consider any particular operating system and hardware on which it is running. So that's how we got the mathematical functions, and these mathematical functions are independent of all these things. Analysis is independent of all these things. But when you convert into a program and test it, it depends which language you have chosen for writing a program, and which operating system, and on what configuration of hardware you are running your program. It depends on that. Like slow hardware, it will take more time, and the fast hardware, that the advanced hardware, then it will run faster. And operating system also, the performance of operating systems also varies, right? So your testing depends on the environment in which your program is running, and this is independent of any environment. So these are the difference between pre-array analysis and post-array testing. In pre-array analysis, we analyze the algorithm for various criteria to know time function and the space function, and this analysis is independent of this one, right? And this is dependent on this one. So take this one. So the points that I have written, just you can elaborate it. If you want, you can write on the description there itself, right? Next. Now, let us see how to analyze an algorithm. What is the method? Okay, let us take it. So how to analyze an algorithm? So I'll write one algorithm and show you how we can find out the time and space of algorithm. Let us take algorithm, some test, okay, which is taking A and B. Then it is finding C as 2 into A plus 5 into B, then return C. This is one algorithm. Now we want to know the time and the space. So first of all, time. Let us see how we can find out the time. It is not a program, right? If it is a program, we can run and see on some hardware. Already I told just now. But we want to know the time mathematically. So what we can do? So we can assume that every statement in an algorithm takes 1 unit of time. 1 unit of time. Okay? Like if the processor speed is gigahertz, then it will execute millions of instructions in a single second. So 1 millionth second of a time every instruction take. So same way, let us say 1 millionth of time. If the hardware is slow, it's not a gigahertz. If it is a megahertz, then less than that, 1,000 times less than that. Okay, so that's how depends on the hardware. So we are not bothered about the program, we are bothered about algorithm. So we can't say 1 second, we can't say 1 minute, we cannot say 1 picosecond, millisecond. Okay, so better say what? 1 unit of time. Unit is what? Unit can be anything. Unit can be picosecond, unit can be millisecond, it can be anything. So that's why let us ignore the seconds or milliseconds, whatever it is. One, it will take one. Yes, one line, one amount of time it will take, right? One amount of time, that is 1 picosecond, let us say. Okay, so we say that every statement in algorithm takes 1 unit of time. Then this also may take 1 unit of time. Yes. Then total how much time? 2 unit of time. So the time function based on n is 2. What is this n? N is the size of the input. What is the size? Just we are passing two values here. Yes, so whatever it is, the size of the input. We are not giving list of values here, right? List of values here. So let us take ignorable size, right? Constant size 2. So the amount of time is 2. And the time that we got not dependent on n. So we represented this. This is constant value, right? This is constant value. So we say that this is order of n power 0. How much is n power 0? This is order of 1. So we say actually order of 1. N power 0 means it's not dependent on n. N is not there. So n power 0, n is not there. So n power 0 is how much? 1. So we write constant. So we don't write this. For explanation, I wrote this one, right? What is this 1? To make you understand, I wrote n power 0. This is not dependent on n. Okay? Now slowly you will understand these things. So I don't have to spend time on that one only. Coming back to this. Now, this is an algorithm, right? And we got the time as 2. So let us elaborate on time. Do you think really this is 1 unit of time only? No. Check it what it is doing. Multiplication, addition, multiplication, assignment. 1, 2, 3, 4. 4 lines here only, 4 operations here only. So if you convert into a program and when you compile the program, compiler will write machine instructions for this. Minimum 4 instructions it will write. Above that, there may be some instructions for moving the data into the registers and to and from register to the memory. Other instructions may also be there. Minimum 4 instructions. 1, 2, 3, 4. Minimum 4. As I said that, before sending a satellite or a rocket to Mars, right, before sending it, you calculated the time. Now same way, before running the program, you calculated the time, how much time it will reach there on Mars, how much time it will take to reach it on Moon. You calculated. Now same way, how much time it will take, we are analyzing that one. So seriously, are you doing a mission on Mars or mission on Moon? No. If you are serious, then consider this also and say it will take 4 units. Are you getting me? So the point is what? How serious analysis you want to do, how much detailed analysis you want to do, you can consider each and everything. Otherwise, just you can say 1 unit of time. It takes 1 unit of time. So usually we follow this method only. This is sufficient. Alright, this is sufficient. So we say this entire statement takes 1 unit of time. That's it. Then this also takes 1 unit of time. Maybe in machine code there may be more than one line. So this is about time. So finally what you have to note down is this is the algorithm, and we assume that every statement takes 1 unit of time for execution. So we got 2 statements and this is n power 0. N is not used here. N is not used here. So n power 0 it is 1. So we say the time is order of 1. I am saying order of. I am not saying big omega theta. We will learn about it later. So order of 1. The time is order of 1. Okay. So this is how we found the time. This is time function. So you have to write on this one. And you can also elaborate. If you want to do detailed analysis, then you can consider each and every operation also. It's up to you. Okay. You take this, then I will show you space analysis. Next, let us see space. So for space, we assume that every variable takes one word. We say every variable takes one word, right? So this takes one word. Every variable takes one word. So what are the variables it is having? A, B, this is space, right? And C, one word, one word, one word, three words. So the space analysis space function is three words, and it is order of 1 again, because n is not involved here. It's order of 1. So for every variable we say it takes one word. What is that word? Maybe 1 byte, right? Or word size is 4 bytes, word size is 8 bytes. Actually, if you are aware of this, word size of processor, right? 16-bit processor, 2 bytes, 32-bit processor, 4 bytes, 64-bit processor, 8 bytes. So word may be 8 byte for 64-bit processor. So whatever it is, when it is converted into a program, that time you worry about. Now we will say just one word. Now one more thing I will tell you. Okay, this is over. Now more on this one. Listen. Don't you think this 2 and 5 also consume memory? Yes. Those are literals, constants, so they also consume memory. So again 2 more, plus 2, plus 2. So it is 5. Then, don't you think that 2 into A is multiplied, a result is kept. 5 into B is multiplied, a result is kept. So where this, then afterwards they are added. So where this value was kept in some temporary variable, in some temporary variable. So for temporary variable also space is required for evaluation of this expression. Yes. So at least what I see is that 2 more variables are required. So 2 more words. That's it. Listen once again. Listen once again. Just simply say A, B, C, 3 variables. 3 is the size. That's all. It's over. If you say, no, I am concerned about more and more detail, then you do it. It depends on your knowledge and your requirement. So first your requirement, then your knowledge, right? So how much detail you want? So if you want, you can add 4 more, then it will be 7. Then this answer is 1 only, but that answer is 7 if you consider each and everything. So that's it. So either you want a brief analysis or you want detailed analysis. It's up to you. It's up to you, right? You follow your own method. Got it? So mostly what we do, brief analysis. 1, 2, 3 variables. So 3 variables, time is 3. Sorry, space is 3. 3 words. And it is order of 1. Order of 1. Because it's constant, it's not dependent on n, just like this. So it's order of 1. So for the space analysis also, we assume that every variable takes 1 word. And if you want detailed analysis, then you can consider each and everything internally in detail. Alright? See, it is just like sometime when we spend, then sometime we calculate that is rough amount. If suppose the amount is 10,000, if it is 12,000 also, we don't care, right? We don't care. At some places we care even about 1 penny also, just 1 rupee also. No, 1 rupee, it's different. Suppose it's not your money, somebody else has given you and you are responsible, you have to reply him back. Then if it's your own money, you may be careless, but somebody else's money, then you will take care of each and every penny, right? So that's how it depends on the requirement. Depends on the requirement. So here also, brief analysis or detailed analysis, it's up to you. So I have shown you that whether you need brief analysis or detailed analysis, you follow any method. For the space also. So I have shown you that even literals take space and the temporary storages, and if the algorithm is recursive, then it uses a stack. That stack space also you can consider. So it depends on your requirement of analysis. So take the space. So what is the point that you have to write on? We assume that every variable, see, don't make bubbles like this. You write on separately. So we assume that every variable in an algorithm takes one word. One word. Word is the word size of a hardware, whatever you are using. So there are three variables, so three words. This over. Then we say that if we want detailed analysis, then we can consider that literals also consume memory, and there is a temporary memory space required for storing the result of expressions also. We can consider that if we want detailed analysis. So note down this. Now, I will write one algorithm. Sum A n s assign 0 for I assign 1 to n do. What is this? Follow. This is not C, C++. Yes, but you can understand. You can understand. This was there in earlier languages like basic language, or this was there in Pascal language. 1 to n, follow. S assign S plus A of I. Return S. Now, see this. What is the data type, or what is A, what is n? A is a variable. But you see this, from this you can say, oh, this is an array. So from the context you can understand what it is. I don't have to say it's an array and all. If you want, you can write on documentation or comments. But from the context you can know that this is an array. This is an array. Then what is happening here? It is finding the sum of all the elements in an array. Sum of all the elements in an array. Right? So this is for finding sum of all the elements in an array. That's it. Now we want to find the time taken by this algorithm and space taken by this algorithm. Let us do it. This statement we know well. Okay, I'll take different color. This statement we know well that this takes 1 unit of time. Yes, we know it. Then what about this statement? What about this statement? See, this is loop. I will take values from 1 to n, and when it becomes n plus 1, it will stop. So if n is a 10, at 11 it will stop. So it will reach till 11 and stop. So we say n plus 1. We say n plus 1. This one. Then what about the statement, this one? This is inside for. So how long it will execute? As long as for is true, it will enter in. So if this is a 10, suppose, so 1 to 10. So this will repeat for 10 times. That is n times only. N times. Then why we wrote n plus 1 here? Because that I becomes 11, then it will stop. So for 11 also we are counting. So n plus 1 we wrote. then this is 1. So then what is the answer? This is 2n plus 3. So time function is 2n plus 3. This is the time. Alright. And it is dependent on n. So this is order of n, or n power 1 actually. See, degree of this polynomial, degree of a polynomial 1, degree 1. So n is the variable, n power 1. Degree I am writing there. Okay. So instead of writing 1, just say n. N power 1 is n only. That time degree was 0. So that's why I wrote n power 0. See, if this is the expression 2n square plus 3n plus 5, what is the degree? Square. So we write n square. We don't write just a 2. We write n square. Order of n square. So that's how. This is order of 1. Order of 1. Back to this. Now listen. In this example, instead of writing 1, I wrote n. Why? Because I have found that this statement is one statement, but it's not going to execute only one time. This is going to repeat for n times. So we found that what is the frequency of execution of statement? What is the frequency? How much it is executing? It's executing for n time. So when you have loops or anything, you have to check for the frequency of execution of statement. So basically, we are doing same thing only. What is the frequency of this one? One time. What is the frequency of this one? One time. What is the frequency of this one? N. The frequency of this n. So we are actually taking frequency of execution of statement. So this method is called as frequency count method. So what is the frequency count method? We count the frequency of execution of each statement in an algorithm, right? In the beginning, I told you that for every statement, we say it takes 1 unit of time. Now, the statement, how many times it is executing, we are finding its frequency. We are finding its frequency, right? So that is frequency count method. All right. So this is frequency count method we have used to find the time complexity of this one. So take this one, the heading is frequency count method. So we count the frequency of execution of statements in an algorithm. Next, one thing I have to show you here, one important thing, watch it. This I said I will start from 1 and reach till 11. That is 1 more than n. So that's why we write n plus 1. But instead of this, if I write for loop of C language, or I will declare I here only, though it is not C++ syntax. Okay, no problem. We don't bother much about the syntax. As long as it's meaningful, it's enough. We write like this, suppose. If I'm writing like this, then this is having 3 parts. Then, see this. How many times this part is executed? 1 time. How many times this part is executed? N times. How many times this part is executed? Condition. How many times it is checked? It is checked for n plus 1 time. So n times it will be true, n plus 1th time it is false. Then you know very well, like C programming, if you know, this initialization is done only once, and updation is done for all n time, and every time the condition is checked, initially also from the beginning, and when it fails, that time also condition is checked, then only it will fail. So this will stop when I becomes equal to n, so 0 to less than n. So anyway, okay, I will write, okay. So anyway, we don't know from where the array is starting, right? This is not mentioned. Now it is understood it's not starting from 1, it is starting from 0. Okay, from the context. So 0 to less than n, I'm writing. Okay, so if I write this, observe it, n plus 1, n plus 1. So this should be how much? 2n plus 1. Exactly, it should be 2n plus 1. But as an old practice, it is n plus 1 we used to write for loop. So still we write 2 into y into times, just say n plus 1 only. So we still write n plus 1. But exactly if you take the for loop of C language, it is 2n plus 1. It's 2n plus 1. Okay, that observation I wanted to show you. Now don't get confused with that. So we say n plus 1. So means we are bothered about what? This one. We are not bother about this, we are ignoring this one. We are saying n plus 1 condition. Because in the old languages, that for loop used to start from 1 to n, so we used to say n plus 1. So still in the books or everywhere, if anybody is teaching or if you have seen it somewhere, we write n plus 1 only there. 1 extra. For what? For termination. That's it. Now, time function we got 2n plus 3. Now what about space function? Space. A is an array, then n, then s, I. These are the variables used. One word, but this is an array of n words. So how much is the space complexity? Sn is equals to n plus 3. Sn is equals to n plus 3. So this is the space function, and again this is also order of n. So take this quickly. Space analysis I have done. I'll remove this. Now, I will write another algorithm. You have to tell me what is the time and space of this algorithm. For I takes values from 1 to n, do. For j takes values from 1 to n, do. C of I j is a of I j plus b of ij. Find out space and time and space complexity of this one. First of all, what is this? A of ij plus b, two-dimensional addition, adding of two two-dimensional arrays. It's matrix. Yes, matrix addition. And the dimension of the matrix is, let us say, n cross n. The dimensions are n cross n, so they can be added. So find out time and space complexity for this. Let me do it. Okay, that side I will do it. This side I am doing. This is n plus 1, we know, right? Just now I have shown you. Then whatever is there inside, we write it as n. Then what is this? Again, this is a for loop. So this itself is n plus 1. So n plus 1. Shall I write n plus 1 plus n or into n? Think over it. I don't have to explain this. This is inside. This will repeat for n times. Then inside this again, this itself will repeat for n times, right? N times, then again one more time, then one more time. So n into n times, yes. But why plus 1? Because this one. Then what about this, the thing inside? So this will also execute for n times. I write once again. I'll remove this. That side I will write. Okay. See, this is n times plus 1 time. Whatever is there inside is n. Over. Then what about this? N plus 1 time. Whatever is there here is into n. That's it. So that is n plus 1, n into n plus 1, then n into n, right? Then how much this is? This is n square, n square. So time function is 2n square plus n 2n plus 1. Alright. So this is the time function. This is n square, so it's order of 2. So order of n square we write. Order of n square. Then next, space. What is the space complexity for this one? See, space complexity is, what are the variables it is having? A, B, N, I, J and C. So A, B, C, I, J. This is what? Two-dimensional array. A is a two-dimensional array of n cross n. Suppose 3. So 3 cross 3. So how much this is? So n square, 1, 1. So this is how much? So space complexity is 3n square plus 1. Sorry, 2. So again, it is order of n square. So space complexity is also order of n square. So copy it quickly. algorithm multiply A, B and N for I assign 1 to N do. For J assign 1 to N do. C of Ij assign 0. Then for K assign 1 to N do. Then C of Ij plus assign, C language syntax, plus assign A of Ik into B of Kj. This is the code for matrix multiplication. Code for matrix multiplication. Find out time and space. Right? So I will not show this one. You have to find out this one. Right? So time and space. Just I can tell you that this you will get order of n cube and the space will be n square only because A, B and C are two-dimensional arrays and I, J, K will be there. So this will be just 3 extra 1. N square only. Same thing we get. Space complexity will be same thing. One variable extra K compared to the previous one. I, J, K is there. Then the time complexity is different, right? So it will be order of n cube. So that's all. I have shown you various type of algorithms and I was writing complete algorithm like thing only. Now next we have to do lot of analysis, but that I will be doing it by writing some snippet, that is a piece of code. I will not write complete algorithm. So we have to learn more on analysis of algorithm. So we'll continue in the next session. Okay.